Welcome to breadboarding. In the previous video we managed to get the DOS mouse drivers working on the breadboard PC, and we managed to also start up Windows 1, 2 and 3, and this is Windows 3. We can see here with the solitaire game, and you can see here that we've got the mouse pointer there, but the mouse wasn't working under Windows, and I also couldn't get it working with the Microsoft mouse drivers, only the Qt mouse drivers from FreeDOS. So this is the Breadboard 8088 PC video 63, and in this video we're going to be trying to get the PS2 mouse working in Windows 1, 2 and 3 and also the Microsoft mouse driver as well. So status in the previous video, and there will be a link to the previous video at the top of the screen up here and also in the description below if you've missed that. We managed to get the Qt mouse driver from FreeDOS, and this particular driver is a very minimal driver. It's only about 3.5K, whereas I think the Microsoft mouse drivers are almost about 55, 59K I think. We managed to get that working in DOS, and also then the mouse was then working in the Norton Editor application. But the various versions of Microsoft mouse drivers were unable to actually get working. So the mouse drivers version 7 were the first to support PS2, didn't detect the mouse. The 8.2 version did detect a modern PS2 mouse, but it didn't actually work. And when starting DOS applications, they would hang when the Microsoft mouse driver was loaded with the 8.2 version. And the 9.0 version didn't detect the mouse either. Now, I'd also ordered an original Microsoft PS2 mouse, and when that came, I was able to determine that my modern PS2 mouse and the original Microsoft mouse, there was no difference in behaviour, so that was something that was eliminated. When I reconfigured the various versions of Windows we've got installed on the Breadboard PC to enable mouse support, so I was able to put the hard disk from the Breadboard PC in an old laptop, and it was actually able to run up Windows 1, 2 and 3 with mouse support. So it's almost certainly likely to be an interaction with the BIOS and the physical hardware, more likely to be the BIOS, which I think is where the problem is. And when running Windows 1, 2 and 3, the DOS mouse driver is not required, and as I've shown already, that the mouse pointer was shown on the screen but we weren't able to move it. So how are we going to get to the bottom of this? Well, to cut a long story short, there's an awful lot of complexity that goes on in mouse drivers, and this diagram I'll try and explain a little bit of the journey that I've been on over the last week or so as I've been trying to get this working. So if we've got a screen and we've got a pointer on the screen, whether this be in text mode or it's in graphics mode will have a pointer. Text mode tends to just have kind of a solid block. And we have a mouse and we move the mouse. So we move the mouse to the left hand side. Now what happens? There's quite a lot. Now I'm not really going to cover too much about the mouse initialization. This is more to do with what happens when everything's already running and the driver's installed itself. But what happens is that the mouse is connected to the keyboard and the auxiliary port. So the auxiliary port, what we now know as a mouse port, but in the early days it was known more as the auxiliary port. And the keyboard controller is our VIA VT82C42. So this is an 8242 keyboard controller, but a slightly more recent CMOS version. And this is configured to use port 60 and 64. Now this is important because depending on the model of the PC you're dealing with, then some of the ports here could be different. But this is pretty much the standard one, which is on all the later IBM model 60, 70, 80 PCs. So we've got both the PC BIOS and MS-DOS actually involved in this. And then the PC BIOS, the first 1K of RAM actually has all the interrupt vectors. So the interrupt vectors include the address and the segment for which a given interrupt is actually going to look to for the routine to call. And this means that these interrupts can in fact be overridden and to be changed or wrapped. And this becomes important in a minute. So we've got the keyboard controller software in the BIOS that uses interrupt 16. We've got the video BIOS uses interrupt 10, and that handles both text and graphics. And we also have a hardware interrupt, so the mouse actually uses the interrupt for the mouse is actually interrupt 12, hardware interrupt, and the keyboard I think uses interrupt 1. So we've got hardware interrupts here, and because this is on the second interrupt controller, it's actually mapped to interrupt 74 in this particular case, so it's a slightly higher range. And then what we did in the previous video, we added the mouse extensions and the extended BIOS data area. So this is a 1K region of RAM in the top of RAM. So with 512K of RAM, it will be from 511 to 512K at the top. And the mouse extensions basically extend a miscellaneous interrupt 15 and add a specific function C2, which is PS2 mouse, and there's a whole load of sub-functions within this, and we'll have a look at that in a few minutes. So then on the MS-DOS side of things, MS-DOS has its own interrupt vectors, but these are more for the software vectors rather than the hardware side of things. And the interrupt 21 DOS interrupt is actually how a lot of the internal DOS functions are called. And in fact, a number of the functions which the mouse driver uses are all to do with getting an interrupt vector, changing interrupt vectors, and we'll see why in a minute. So when we run up mouse.com, there's a number of areas of mouse.com. So the mouse.com itself is actually quite a complex thing, and I'll show you a little bit of this in a minute. So the command line and the initialization is a relatively straightforward bit, and what this does is takes the command line arguments. It also does some initialization, so detects whether or not we've got a serial mouse, PS2 mouse, and it also uses various elements of the hardware configuration to try and work out what that should be. Now, from what I understood, the version 7 Microsoft mouse driver seemed to use quite a lot of pretty varied information, quite odd things, DMA controller 3 and all sorts of things it used to try and work out what was going on. The version 8.2, which is the one that I'm using and going to focus on, that seemed to be a lot more sensible and actually used the model ID that was in the BIOS and which is in the configuration area. So what this does is it adds interrupt 33 mouse functions. The interrupt 33 is the DOS standard extension for interacting with the mouse. So if you write a DOS application, it expects to find the interrupt 33 mouse functions if you've installed a mouse on your PC. And what it also then does is it has to intercept the video routines on interrupt 10. And so what it also does is actually changes the interrupt vector here, effectively wraps the standard interrupt 10 stuff with its own things here, so it can intercept stuff and then pass things over to the default interrupt 10 routines once it's done with them. And then it actually keeps a terminate stay resident, a TSR. So this is a program in the old DOS days that if you needed to have something there in the background, then the program could, when it terminates, could stay resident in memory. And this is what drivers, particularly like mouse drivers, would do. So this bit here is the bit that actually then handles the day-to-day mouse operations once the initialization is in place and once these various interrupt routines are in place as well. So what then happens is the movement of the mouse here is actually sent to the keyboard controller, and our programmable interrupt controller number 2 over here, so we've got number 1 and number 2, and the XI8088 design was a little unusual in that the original XT only had one interrupt controller, but this meant that we couldn't easily do the interrupts for the PS2 mouse and certain other devices. So interrupt controller number 2 has a slightly higher range, so this is why the interrupts are in the 70 range. And what happens is the keyboard and auxiliary port controller here raises an interrupt 12, a hardware interrupt. The programmable interrupt controller sends the interrupt request to the CPU. And what the CPU does is actually sends back an interrupt acknowledge signal, and on the second interrupt acknowledge signal, and we'll see that in the logic analyzer in a few minutes, the interrupt controller here will actually say, yes, vector 74 is, so the configuration at initialization says when we get the interrupt 12 coming in on the particular pin here, I think it's the interrupt 4 line on the second controller here, it'll actually send 74 on the data bus when the CPU is looking for which interrupt vector to use. So basically what this then does is this interrupt 74 routine here, which is part of the BIOS, then does various things, but then it actually says, right, has the mouse here configured the extended BIOS data area? As part of the initialization of the mouse driver, what it will have done is also identified in the extended BIOS data area the segment and the address for the mouse driver routine. So then the mouse driver, the memory resident mouse driver, will then actually call some of the interrupt33 mouse functions, and these functions themselves actually then go back and call the BIOS interrupt15 functions, and all of these functions are prefixed for C2, and we'll have a look when we look in the source code. You can see that for each C2 there's then another register which is then used for the individual function within the mouse extensions. The code in the BIOS there will then actually communicate with the keyboard controller, so it will send commands and it will get data, and it'll actually put the data into, there's an area in this extended BIOS data area where it actually keep the data here, because the wheel mouse and multi-button mice may send 4 bytes or more of data, whereas the standard sort of 2-button mouse will generally only send 3 bytes of data. So for each byte, this interrupt will actually do this and will build up the data here, and then once we've actually got a complete message from here, it will actually send it back to our interrupt routine over here, and then what that will then do is to tell the video code to actually move the mouse on the screen, and the code in here will actually has the image of the mouse, and then having done that, then that will actually move the pointer on the screen. So all this stuff is going on, so it's hardly any real surprise that only one little bit in this whole bit needs to go wrong and the mouse won't work. So what I've been able to do is to get to the bottom of this. There's a lot more detail in here than I was thinking I was going to need to go into. I won't bore you with all the even more excruciating detail of this. I'll just show you how you can actually look at these sorts of things and actually work out what is going on. So let's have a look at the Qt mouse first. So Qt mouse I covered in the previous video, and the links and things will be in the description below. You can download it from there and also look at the source code. You can look at the CT mouse assembly language driver here. Now one interesting point here is it actually includes these DOS characters here, and one little tip if you don't know about it, if you go into here, and normally you'll have this in 1252. So Windows uses code page 1252. So quite often if somebody's used the old MS-DOS line draw characters and things in there, then it'll appear like this. If you go into encoding, character set, Western European, and set the OEM US, then you'll actually get this coming out a bit more cleanly. So by going through all the source code here, you can actually go through all the various bits of command line parsing, all the various bits that we were looking at here. So you can see where the command line is, you can see where the interrupt33 routines are, the video routines, and the terminate stay resident bits as well. So this is where I kind of worked out what all this stuff is. So in addition to the source code here, there's also some very useful documents that come with it, and in particular the tech note here tells it these are all the interrupt33 DOS services that this mouse driver implements. And also, more importantly, what it also does is tells us all of the interrupts, so interrupt 10 and interrupt 15, that are actually used from the BIOS. And in particular, the ones that we're interested in are these C2 ones, and you'll see there's another code here. So the next bit here is just the function within the mouse driver, and you can see that it's using 00, 03, 05 and 07, and this becomes important when we come to the reason why the Microsoft mouse driver is not working. So then let's go to the Microsoft mouse drivers. So there's no source code for these, and really trying to work out what's going on here is quite difficult, but I have done some disassembly of these. So this is the 704 disassembly, so this is just using the NASM disassembler. Now it's a little messy. What we can see here is you can see there's interrupt 15, so this is where we're calling some mouse services and calling some more mouse services. And you can see here there's a C207, which is one of those routines that we're identifying. That one in particular sets the driver addresses. And so you can see here I was working through this. Now the 7 driver was quite messy. It was doing a lot of weird stuff to do with all sorts of hardware things and trying lots of things out, trying to detect what type of computer it's in. The 8.2 driver was a lot cleaner, and we'll see that this is actually the cause of the problem in a minute, which I'll explain. And what I also did is as IDA Pro is a freely downloadable version of a disassembler, which is very, very powerful. I only just started to scratch the surface of this. But basically, what this allows you to do is to disassemble the COM file, And if I put this into graph view, this actually becomes a little easier probably to see what it's all about. What this gives you is it actually goes through and works out what all the different routines and things are, and then you can go through and actually augment this and rename things. And what you can see over here is we've actually got where the driver starts and where it's doing some DOS interrupts. You can see a DOS 21 get a vector, so it's getting an interrupt vector here and various other things. And you can see all the way down here, you can trace all the stuff down here. And what I was doing is actually having a look at the end here as a load of exit codes. And these exit codes basically are like the error level that you get in DOS. And in particular, I think the exit code that I was getting was 16 or 10, in fact. And so this helped to actually work out where the problem could have been doing. And it was interesting just to sort of learn how this works. Now, the only issue is that all this code here is actually this code here. But not really this code here, this code here, and this code here. And I haven't really spent long enough understanding the program to work out how to get it to add all that sort of stuff. So help me to understand the way how all this sort of stuff was constructed, but I probably didn't spend as much time on this as I probably need to fully understand it. But it's a very powerful program and allows you to actually augment things. So once you actually get something here, you can perhaps rename it to something more meaningful once you've worked out what the meaning of this is. So what really helped me to find out what the problem was is I added some more debug output onto the mouse driver. So if we go to the BIOS, so this is the BIOS, and this section here is the PS2 auxiliary port functions. And what we also need to do though is to actually look at this miscellaneous interrupt 15 thing. So this is actually some various services, and it also includes sort of a placeholder for all of the PS2 mouse services, and there's also a thing in there for getting the system configuration. So this is how the mouse driver can determine what the model byte of the PC is, for example. And so what this does is just if something calls interrupt 15, so this one here is the get the configuration information, and then this one here is the mouse. So at the moment this looks like a fairly simple just call to interrupt 15 function C2 mouse handler, and that's what's in here. And there's a total here of what 500 odd lines, so it's not particularly trivial. What I did here is I started to actually put some extra power on self-test register output. So basically what I've done is I've instrumented the code in here to output useful information to the power on self-test register, which allowed me to actually get to the bottom of what was actually going on here. So what I'm going to do now is all of this stuff's actually been loaded into the BIOS. I've burned it into the BIOS. And what I'll show you now is some of the logic analyzer output that actually allowed me to fix the problem here. So I'm just going to power up the breadboard PC. So switch over to the screen capture. And you'll see there PS2 aux device present. Okay, so all we're going to do is to go into the mouse 820 folder. And we've got mouse.com in here. So mouse test.bat. You can see there's various things with error levels, which I was using for checking to see what the return codes and things were coming from this. But what I'm going to do here is we're going to run up the mouse driver, and then I'm going to run up Norton Editor. But first of all, what I'm going to do is to set the logic analyzers running. So I've actually got two of the logic analyzers running. So the first one is fairly simple. So my LA1010, this is a fairly slow one, but this is just looking at the power on self-test port. So we've got the chip select for the power on self-test port, but it also has got the PS2 data and PS2 clock. And because the logic analyzer here knows about the PS2 protocol, then it'll allow us to actually see what's actually going on. And then the 32-way logic analyzer, this is showing all the address lines, the data lines. We've got the memory read and write signals, IO read and write. We've got the power on self-test chip select, which again, we're triggering everything on that. And this just means that the two logic analyzer outputs will be kind of synchronized on that start point. We've got the keyboard controller chip select, so that's also the mouse controller. And I've also added the interrupts and the interrupt acknowledge, and that will be interesting to look at just to see when we're getting the interrupt 12 So we're just going to run those, get them waiting. We'll go back to VGA capture. So they're just waiting, and all we need to do now is to press enter, and then I will also go into Norton Editor after it's loaded so that we've actually generate some traffic. Then we're going to Norton Editor and then just move the mouse and do a bit of clicking. So Norton Editor, exit. So hopefully that should mean we'll have some mouse activity as well. Okay, so this is the power on self-test port, and we can also see that there's various mouse data here. And you can see that we've got the reset mouse, then we've got the basic assurance test, set resolution, set sample rate, get device ID. So device ID of 0 basically means it's a normal mouse, and I think device IDs of 3 and 4 were things like wheel mice. Setting the sample rate, enable data reporting, etc, etc. So we can see what's actually going on there, and we can also see that we've got the various power on self-test data. And what I did was I extracted some of that and I had a look at this, and for example we've got the init mouse, set resolution, set the driver, various things, and some of the things there were things I didn't quite understand. The driver address, this is for the Qt mouse, which was obviously the working one, and you can actually see here as well that when the interrupts were occurring I was actually getting it to output useful information from the interrupt, so what the address of the BIOS data area was. So what this basically allowed me to do is to work out what was actually going on and compare the Qt mouse with the Microsoft mouse driver to actually see what was going on. And if we look at the other logic analyzer output, this probably more clearly indicates where we can actually see what's going on. So for example, if we look a bit later on here, we can see that we've got quite a lot of interrupts going on here, interrupt acknowledging. So if we look at this interrupt here, let's see if this is one. So we have an interrupt starts, and then towards the end of the interrupt we get 2 interrupt acknowledges. And on the second interrupt acknowledge, what the interrupt controller does is actually puts on the data bus the actual interrupt that should handle this. So you can see here that what's happened here is when interrupt 12 has come in, you've actually got 7.4 put on the data bus, and that's how the CPU knows which interrupt service routine to actually use. And we'll also see here that there'll also be various things going on with the mouse port and keyboard port. So you'll see port 64 is, I think, the command status port, and 60 is the data port. So you can see there it's read a value off the data port of 8 in that particular case. So to cut a long story short, going through all this sort of stuff and analysing it, what I was able to do is to work out where things were going wrong. I was able to narrow it down that the calls to this C206 set scaling or get status was actually where the problem was occurring. If we comment out this line, and also just to be safe this line here, then this was actually what was sending the command to set the scaling factor to the mouse. Now the reason why the Qt mouse driver didn't have this is because the Qt mouse driver doesn't use this particular one here. So if you look at C206, so C2 means PS2 mouse, 06 is a function. And if we look back at the Qt mouse document here, what you can see is the Qt mouse doesn't make use of this. So the reason why the Qt mouse driver was working and the Microsoft mouse one wasn't is because the Qt mouse didn't bother with this C206. And so the fix for it was actually relatively straightforward. Like all things, when you know the answer, then the solution is much simpler. So basically all I have done here is I've kept the status function in here, and I've still got all the various power on self-test port, so that I've still got the instrumented output here. I may remove it at some point in time, but it's useful to have it just to get the information in the logic analyzer. And all I've done is the bit where it sends the scaling factor command to the keyboard controller and mouse, I have just commented those 2 out, but everything else is the same. And that actually appears to have fixed the problem. As we can see in the Norton Editor, So now I've got two keyboards and two mice to deal with, which sometimes confuses me. So we can see here that we can use the mouse. We probably need to adjust some of the sensitivity settings, but we look at config.sys, for example. You can use the mouse under DOS. Then, as we did in the previous video, what I'll just do is I'll try and run up various Windows versions. So we'll start with Windows 1, which is just in a straight Windows directory. Okay, so we've got our Windows 1.1 here. Now, the only difference with Windows 1 from other Windows versions, when we press the mouse, we have to keep it pressed down. You can't just click on it. And if we go to just show programs, see the control menu here, and see that we don't have any function keys, and we've got icon, zoom, minimize and maximize. So if we go in and have a look at Notepad like we did before, now Windows 1.0 can only tile windows, they can't be overlapped apart from dialog boxes. So if we make this an icon, then when we've got this square at the bottom, we can just drag this up and it will maximize it. Take this one here and put it over on the right hand side, then it will tile it. And then if we want to use these resize icons here, we can change the size. And this one we can change the size back over. There we go. So the mouse is working. Just have a look in control panel, see if there's any mouse settings here. There we go, so you've got cursor blinking and double click. So we can make it slower or faster if we want. We close that. And then we can use Alt spacebar still and Alt tab. If we drag this up, then we can end the session, and then we'll look at Windows 2. What I should say is when I'm starting up Windows 1 and Windows 2, this is in real time. Windows 3, I will be speeding up the speed up because it takes about 35-40 seconds to start up. You can see in Windows 2 here that the icons for the maximize, minimize are here rather than resize. It's actually possible to resize windows by dragging over the borders here. And the control menu is now got the function keys and minimize and maximize rather than icon and zoom. We start up Notepad. See that Notepad now overlaps other windows, so we can have overlapping windows. We can still Alt tab between them. We can now resize the windows by dragging the borders. So if you just have a quick look at the control panel, so now we can change our double click speed Make it a bit slower, I think. Okay, so we'll now just exit this and we'll go in and have a look at Windows 3.0. Now you can see here that when we click on a menu here, it stays up, whereas in Windows 1 you have to keep the mouse button down. So it's certainly a lot easier to do it this way. So now we're going to go in and have a look at Windows 3.0. Startup will be sped up a bit because it does take 35-40 seconds for Windows 3 to start up on the 8088 processor on the Breadboard PC. Okay, so this is Windows 3.0, looks a little more familiar, and last time we actually did have a look at the games and solitaire. So you've just run that up, it's a bit easier to navigate with the mouse. It's a bit slow, but it is possible to work with this. Now the PC does get a little bit unstable sometimes, so it's something I'm going to be looking at in the next video, ways of avoiding this. We can see it's possible to play the game like this. You can see the icons have changed yet again, so this is minimize and that's either maximize or restore. And if we have a look, so we go into control panel, we can see there's mouse options on here. Now colour won't be much use because we won't be able to see anything, but we can see that there are a few more configuration options, and mouse we can actually change the speed of the mouse and test the double click, so I've already changed it to be a little slower tracking, make it a little easier. You can see here that's all working okay. Now if we go back and have a look at a summary here. So basically what I've done is, this is just summarising some of the changes. I also changed the model byte in the BIOS configuration. So originally I did have it actually set to PC-AT, and I tried quite a number of different settings. But in fact one of the things I found was that the Model 50 PS2 had the same code here, FC, as a PC-AT, but rather than 0 for the submodel it had 04, and I found that this actually worked. I'm not sure whether this was necessary or not. I do know that the PS2 Model 25 and 30 had different port mappings, and so that certainly wouldn't have helped. So in the BIOS configuration here you can see that I've actually defined the model byte as PC-AT, and with the sub model byte of 04, then that actually makes it a Model 50 PS2, and that appears to work. I could change this back and see if it broke it, but it's working, so I don't really want to break it. And what I have done is added a model sub byte here, and if we look for this in the listing here, you can see here we've already got it selected, and in the configuration table, which is one of the routines I showed you in int 15 gets the configuration, you can see now that we've got the model byte and the sub byte returned to FC04. So this makes this, according to any program that calls the Breadboard PC, it will think it's an IBM PS2 Model 50, and certainly from the point of view of dealing with a mouse that appears to make it work. And we've also seen that this scaling get status function wasn't called by the Qt mouse driver but was called by the Microsoft mouse driver, and so all we've done is we've just commented out the send command here, the third from last line, and that seems to have made it work. And when I've tested this, the Microsoft mouse drivers, that both the modern PS2 mouse and the classic Microsoft mouse, I now have a classic Microsoft mouse, they both work exactly the same, or not as the case may be. So the 704 driver, this was the first one supporting the Microsoft mouse, that now works in DOS and with Norton Editor. 8.2 works, is detected and works with Norton Editor. The 901 still doesn't work. Now I haven't gone in to have a look at why that might be, but I suspect there'll be a similar sort of thing there. So what I'll be able to do is to show that I've now got the mouse working in DOS and in Windows using the Microsoft mouse driver, and the reason for getting the DOS Microsoft mouse driver working is because this will be very similar to what's working in Windows. So if we just have a final look at the Windows 3, so we can see here we've got the mouse working and we can now get it to work. It's a bit confusing when you have two mice on your desktop, but we can see that this is now working. So I'm going to break the video there, so thanks for watching, and in the next video what I'll do is I'm going to take a little bit more of a detailed look at the differences between Windows 1, Windows 2 and Windows 3, and I'll be summarising the whole of the Breadboard PC series. There's quite a lot I've learned from this. I hope it's been of interest. If you don't want to miss future videos, please hit subscribe, and if you hit like as well, it just helps to make the videos available to more people. Thanks for watching.